In this video, we're going to talk about 2.4 Objective 3, where we evaluate limits analytically. Let's go ahead and get started. Suppose that f of x equals approaches negative 150 and g of x approaches 0, with g of x being greater than 0. So it's approaching 0 from the positive direction. So this is going to be a negative number divided by a positive number is going to be a negative number. Getting close to some kind of infinity because we're getting close to divided by 0. So this is going to get close to negative infinity. Which of the following statements are correct? So we would say, technically, it again depends on your teacher, you're dividing by 0 there, the limit doesn't exist because the definition of a limit says it needs to approach a finite number L. We could say that, but we're going to say here that it doesn't exist is correct, but also it's correct to say that as it approaches -1, that this is getting close to a positive number here, and a negative divided by a positive is a negative. And so it's also correct to say that it's going to negative infinity. So both of those are correct. Determine the following using positive or negative infinity where appropriate, or state that they don't exist. As I approach 5 over x minus 4, as x approaches 4 from the right, the denominator is going to be positive. A positive over a positive, where the denominator is getting close to 0. It's going to go to positive infinity. As I approach 4 from the left, this denominator is getting closer to 0 from the negative direction. So a positive over a negative is negative infinity, which means that it's neither infinity nor negative infinity for the limit, and the limit does not exist. So we get close to 3 from the right here. That's a positive. A negative divided by a positive is a negative infinity here. And then as I get close to 3 from the left, that's going to be a negative over a negative. It's going to be a positive infinity. So again, the limit doesn't exist. It's neither positive nor negative infinity. Since we're squaring the bottom, a negative times a negative will be a positive. That denominator is always going to be positive here. So this is going to be a -1 over a positive number that's getting close to 0 is going to be a negative infinity. And again, a negative infinity. And this is going to be negative infinity. Look now at number 6. So as I get close to -2 from the left, this is going to be a negative, and a negative is going to be a negative infinity. As I get close to -2 from the right, this is positive, negative, so that's going to be positive infinity, and the limit's not going to exist. Now we're going to get close to -2 from the right. So that's going to be a negative, and positive. That's going to be a positive infinity. Get close to -2 from the left. That's negative, negative. That's negative infinity. And that limit's not going to exist. For number 8, if I factor that numerator, I'm going to get x minus 3, x minus 5, for x minus 2 squared. limit as x approaches 2, then from the left or from the right. So as I come from the right, positive, positive, positive is positive. As I come from the left, sorry, this is negative, negative, positive, but that's still positive. As I come from the left, this is negative, negative, positive is still positive. And because positive infinity from both sides, this is positive infinity there. Let's go ahead and determine the limit using positive infinity or negative infinity where appropriate. As I approach 7 from the left, this is, I'm sorry, negative 7 from the left. This is a negative times a negative is a positive inside that square root, which is good. That negative divided by that positive is a negative, and we're getting close to negative infinity. So I get close to negative 7 from the right. That's a negative. Times a positive is a negative. Can't do that because I'm going to get a negative on the inside of the square root. So that limit shouldn't exist. And so then we can't say that the limit exists because it doesn't come from both sides. It only comes at negative infinity from the left side of negative 7. X minus 9 over x squared times x squared minus 81 is x minus 9 times x squared times x plus 9 times x minus 9 is the same as 1 over x squared times x plus 9 as long as x is not equal to 9. So if we're sticking 0 in there, which is not 9, I don't have to worry about that hole that's there. That's going to be a positive number there, positive number there. That's going to go to positive infinity. As I get close to 9, that I have to consider from the left and the right. This is changing sign here. This is not. So that limit is not going to be either negative or positive in infinity because from, oh, that's 9, not negative 9. Positive, positive is positive. So this is going to be getting close to, let's see, 9. That's going to be 1 over 81 times 18 is 1 over 1458. That's what I was just saying. There's a hole there at 9. It's not an infinite limit. As I get close to negative 9, that's what I was thinking here, is that this is going to change sign. And it's going to be neither positive nor negative infinity there. Because as I come from the left, it's going to be negative infinity. As I come from the right, it's going to be positive infinity. All right. X squared times x minus 4 for x squared will be x minus 4 as long as x is not 0. When I do get close to 0 here, we're going to get close to negative 4. Like that. And This is x to the fourth, x minus 10 over x to the fourth. It's going to be x minus 10. X is not 0. This is x minus 10. I'm going to stick 0 in. It's going to be negative 10. Five times x squared minus 25, where x minus 5 is 5 times x plus 5 times x minus 5 over x minus 5. It's 5 times x plus 5, as long as x is not 5. As I get close to 5, 5 times 10 is going to be 50. And 2 times x squared minus 25 for x minus 5. 2 times x plus 5 times x minus 5 over x minus 5. It's 2 times x plus 5. And getting closer to 5, 2 times 10 is 20. Moving right along. As I approach 5 from the right, let's make sure that this doesn't cancel. X minus 3, x minus 2, x minus 5, limit x approaches 5 from the right. That's a positive, and a positive number. That's going to go to positive infinity. Um, oh, the expression inside can't be simplified anymore, really. So that's positive infinity. I can break it down like that, but that's not simplified because nothing cancels out. So let's see the next one. I approach 1 from the right. This is x minus 3, x minus 5, for x minus 1, limit as x approaches 1 from the right. It's going to be a negative, and a positive. It's going to be a positive infinity. So I approach 5 from the right here. That's a negative over a positive is a negative infinity. Secant of pi over 2. Let's look at the graph of secant. It looks like this. This is a pi over 2. This is 3 pi over 2, and so on. As I approach pi over 2 from the right, I'm going to negative infinity. Negative pi over 2 from the right, sorry. Negative pi over 2 over here from the right here. Negative pi over 2 from the right is going to positive infinity. Yeah. All right. Limit of negative 1/5 tangent to negative 7 pi over, no, positive 7 pi over 2. So 1, 3, 5, 7, 9. And I want to come at it from the right. So we're going to negative. Now that would be regular, but I'm going to multiply that by negative 1/5. So a negative times a negative is going to be a positive here. Okay, let's keep going here with 20. As I get close to 0, that's 4 over 3 minus 3. So let's break this down into 3 times 1 minus cosine squared theta is 4 plus sine theta. Limit as theta goes to 0 is going to be 4 plus sine theta over 3 sine squared theta. Limit as theta goes to 0. And we might have to look at this graphically. We might have to look at it with a table. I'm going to try and divide here, though, and say that this is 3. This is 4 cosecant squared plus cosecant. And limit's not going to let's see, 4 cosecant squared plus cosecant is a cosecant times 4 cosecant plus 1 over 3. Limit as theta approaches 0. Let's look at cosecant. Cosecant has an asymptote at 0 and at pi. And it is like this, and like this. As I approach 0 from the right, did it say? Didn't say. This is going to be either a negative times a negative, which is a positive, over a positive is a positive, or a positive times a positive will be a positive over a positive. In either case, it will go to positive infinity. Put that one in your calculator. Look at the function and see what happens as it goes towards 0. In fact, let's do that right now. To show my calculator here too. It's going to be 4 plus sine of x divided by 3 minus 3 cosine of x times another cosine of x. Close that up. And we're going to graph. And you can see that as I approach 0 from either side, I'm going to positive infinity there, right? Coming at 5 here, this is a negative over a positive. It's going to be a negative. So that's 21, 22. This is x minus 5, x times x minus 3. As I approach 3 from the left, this is a negative, and a negative is a negative infinity. Three from the left. No, 3, not negative 3. So this is a negative, positive, negative is a positive infinity. Last but not least is 25 over tan of 0 with that tan of 0 coming from the left. So that is going to be a negative, a very small negative number. So this is going towards negative infinity. That's everything for this video. We'll come back next time and talk about 2.4 Objective 3. See you for the next video.